Unit 4. Work, power and energy. Work, power and energy. This is unit. Work. This is ground. This is an object. This is force applied, and this is what? Displacement. We have read it in 9th. Work. Work is said to be done when a force, this is the force, this is the displacement, when a force moves a body in direction of force. ये मोशन है बॉडी का, यही फोर्स की डायरेक्शन है. दिस इज व्हाट वर्क. वर्क इज सेड टू बी, रिमेंबर दिस डेफिनेशन, already read in 9th. Work is said to be done when a force moves a body in direction of force. That is work. Fs. Force, F is force, S displacement in direction of force. Let force makes angle theta with displacement. This is object, this is the direction of force, and this is direction of displacement. This is S, direction of displacement. What? Theta is angle. Let force makes angle theta with displacement. Then work done. That is W. Take this force in direction of displacement. This will be what? F cos theta. Resolve. In this direction it is F cos theta. In this direction it is F sin theta. We require force in direction of displacement. So F cos theta, this is the force and this is displacement, both in same direction, or W Fs cos theta, or W F dot S. So this is what? Work. Suppose this is direction of force. Take S to this side towards theta, S cos theta. Again same. W is Fs. This is general definition. Dot product, dot force and displacement is work. Dot product of force and displacement called what? Work. So this is work. Another question, work is scalar or vector y. This is the question. The answer is, we know work F dot S as work is dot product. Dot. Here this is dot. So work is scalar quantity. We have read dot and cross product. Cross products are vector products. Dot are scalar products. Units of work. Absolute units. SI unit, joule. CGS, erg. Dimensions. Work, Fs. This is what? F force, S. These are dimensions. Define joule. Rough work, WFS, 1 joule. Force, SI unit, 1 Newton. Displacement, 1 meter. Connect them. This is definition of 1 joule. Again work. Work is said to be done. ये क्या है ये? Work is said to be done here. This one. 1 joule of work is said to be done. What is this? 1 joule W. Work is said to be done here. 1 joule of work is said to be done when? A force moves body in direction of force. When? This one. 1 Newton of force moves. This one, a body 1 meter in direction of force. This is defined joule. WFS, 1 erg, force, dyne, displacement, centimeter. Again definition. What? Define what? Erg. Similarly, this one, 1 erg of work is said to be done when? This one, I have written this one. When 1 dyne of force moves body, how much? This much. 1 centimeter in direction of force. So this is what is work, whether it is scalar or vector, units, definition of those units. Find work done in following cases. In following: first, work done by gravitational force. This is first question. This is Earth. This is a body. This is that gravitational force. And this is what? Displacement. This is object. Any body mass say m. Gravitational force, work done by gravitational force. We know work done. Fs cos theta. Fs cos 0. Angle between F and S 0. So it is Fs. This is positive work. Or if you want to give values for force, m is mass, F is mgs. So this is what work done by gravitational force. It is positive work. Work done against gravitational force. This is again Earth. This is a body, and the body is taken in this direction. From Earth. the gravitational force is acting in this direction. If m is mass of the body, then again work done Fs cos theta, Fs cos 180, because this is the direction of displacement, this is direction of gravitational force. It is minus Fs or it is minus mgs. This work is negative work. If we want to find nature also, the nature is what? Negative work. Work done by centripetal force centripetal force revolves a body in circle. This is direction of centripetal force. This is direction of centripetal force. This is direction of centripetal force towards circle always. Here, this is the direction of displacement. Here, this is the direction of displacement, tangent. This is direction of displacement. This is what? Direction of displacement. A force, the force, centripetal force. Centripetal force towards center. Again, we know W, F dot S, Fs cos theta. Theta is the angle between F and S. Fs cos 90. Fs 0. The work done is 0. Work done by body moving with constant speed. Again work done Fs cos theta, speed constant, then force 0. Why? No acceleration. Fma, no acceleration. If speed is constant, there is no acceleration. Force is 0. The work done is 0. Man holding weight in hands for 10 minutes. Again, this is ground, this is man, this is weight. He is holding to W Fs cos theta. This is 0. He is not in motion, he is just holding the weight. The work done is 0. Man, weight, holding weight and moving in horizontal direction. Again, this is man, this is weight, and he is moving in this direction. So theta is what? 90. W again, Fs cos theta. It is Fs cos 90. It is, he is doing no work. Work done by variable force. This is a plot. Draw a plot between variable force and distance. This is that plot. Say this is A, this is B, this point is B, this is C, this is D. Cut a small displacement here, dx. This is question, draw a plot between force and displacement. ये ऊपर वाले क्वेश्चन के लिए है, ये नीचे. तो the work done is here F dot dx integration, or it is what? Area. Force into displacement क्या होगा? ये this one area है. This into this, what? Area. Area A, B, C, D. This means if there is no other method, then we can find work by using this thing. We can find area, that will be what? Work. Variable force है, ये यहाँ कितनी है, यहाँ कितनी है. Constant force होती तो there will be what? Straight line. Again then area covered will be what? Work done. So these are some work done. A woman pushes a trunk on railway platform which has rough surface. She applies a force 100 Newton up to 10 meter. Thereafter she gets tired. Her applied force reduces linearly with distance to 50 Newton. Total distance of trunk trunk moved 20 meter, plot force applied by moment and frictional force which is 50 Newton against distance. What is plot? Force against distance. First thing is this. This is force, this is distance. We have plot this. The total distance is 20 meter. The total distance is what? 20 meter. Total distance trunk moved is 20 meter. What the question is saying? She applies force 100 Newton up to 10 meter. This is 10. The force is 100 Newton up to 10 meter. Try plot. This is 100 Newton. She applies a force 100 Newton up to 10 meter. Draw plot. Plot होगा. The force reduces linearly with distance to 50 Newton. ये linearly reduce हो गई. How much? This is 50 Newton. Draw a plot. So this is what? That plot. 100 Newton up to 10 meter. Plot force applied by moment and distance. Again frictional force with distance. This is that frictional force. And this is what? 20. Up to 20 meter there is frictional force. And what is that frictional force? It is 50 Newton. So this is minus 50 Newton. Frictional, this acts in opposite direction. So this is first part of the question. Draw a plot, applied force, 100 up to 10 meter, 50. Calculate work done by two forces. Work done by applied force. Area A, B, C, D plus, say this is G. Area B, G, HC. This is work done by applied force. ये एरिया बनाया उसने applied force में ऊपर. So these are two areas. Area ABCD 100 into 10 plus. This is 100. This is 50. 100 plus 50 average into how much distance? 10. So this will be net force, or this is that area. So it is 1000 this is 150 by, it is 75 into 10. So the force is this much Newton. Work done by gravitational force. Work done by frictional. Frictional force. Ij. This work done is area. What? This much area. AGJI. This area. AGJI. And it is what? This is minus 50. This is what? 20. So it is. Why minus? Because this is work done by friction. Displacement direction, this, force of friction in opposite direction 180. So minus is there. So this is a numerical. Another numerical, a force F .5 x Newton acts along x-axis. Find work done by force during. Find work done by force during displacement x0 x 2 meter. Work, it is what? F dot dx. Limit 0 to 2 meter. This is F dx. Why? F dx cos theta cos 0. Why? The force is along x-axis, displacement is also along x-axis. Alright, cos theta. F dx as force displacement both along x-axis, so theta 0. F is what? 10, 0.5x dx 0 to 2. It is 10 dx 0 to 2 plus 0.5 x dx limit 0 to 2. 10 outside, integration of dx, it means again x0 dx. What is rule? Add 1 to power, so it comes out to be x. Divide by same power. Dx constant outside, integration of dx is x. Why? It is integration x0, add 1 to power, divide by same power, 0 to 2. Outside, x dx, add 1 to power, divide by this. It is 10, it is 2. Limits, value of x is this, minus value of x is 0. 2 outside, value of x is 2, square is there 4, value of x is 0 square, it is 20, it is into 2, 1, so it comes out to be what? 21 joule. Another question, find work done by a force F minus 3I plus J plus 2K Newton. Find work done by a force minus 3I plus J plus 2K Newton when displacement minus 2j plus k, what? Meter. Solution, we know work F dot S, F minus 3i plus j plus 2k dot S I minus 2j plus k. I dot I is 1, so this into this minus 3. I dot j 0, I dot k 0. Now j dot I 0, j dot j is 1, j dot minus 2j, it is minus 2, j dot k is 0. This one, k dot I is 0, k dot j 0, k dot k 1, so it is what? 2k dot k, it is 2. So the work done is minus 3 joules. Again, multiply this with this. I dot I 1, so minus 3. I dot j 0, 0. Now this j dot I is 0, j dot j is 1, but it is what? Minus 2. This dot k 0. K dot I is 0, k dot j is 0, k dot k 1, 2k hai here, so it is plus 2, and the work done is this. Another numerical, a body of mass 2 kg initially at rest moves under action of constant force 7 Newton on table of coefficient of friction 0.1 for 10 seconds. Calculate. Number 1, total work done. Net work done. Work done by frictional force. The body is at rest. The time is 10 seconds. Applied force, small f, is what? 7 Newton. Force of friction is mu r, it is mu mg, it is mu is 0.1, m is 2, g is 10. It is 0.2. So force of friction is 2 Newton. Net force on mass on body this is applied force, this is what? Force of friction. Applied force is 7, force of friction is, this is net force. Work done, Fs. This means we have to find S. So S is ut plus half at square. So A, hence A, net force by mass, FMA, it is 5 by what? 2. It is 2.5 meter per second square. Now S, ut plus half at square. S, we have to calculate. U was 0, T was 10, half A, 2.5, T square, it is 100. T is 10 seconds. So S is what? Meter. So first, work done by net force. F minus F into S. This is 5. This is what? 125. Multiply 5 with this. This is 625 Newton. Work done by frictional force. Minus Fs. Minus frictional force S minus F. It was minus 2 into S. (250 Newton). Suppose only applied force होता, work